Okay, so in the last class we did water jug problem, and I give you one problem to solve, and I said that I'll give you the solution for that. So if you want a reference, then you can check it out on slide number 12. You can see it here. This is the solution for that. You can follow this procedure. Okay, so moving on to the next. Today we are going to start with second chapter, that is heuristics. Okay, heuristic search techniques. Mm, yeah. So, okay, so as I have said, uh, that heuristic search is what, um, you can say, okay, just heuristic search is the estimation of how close the agent is from the goal, okay, by taking the current state of the agent as input, okay, or you can say heuristic search estimates the closeness of the agent to the goal state. Let me just correct this. Mm. Oh, it's fine, it's fine. Okay, so heuristic search is the estimation of how close the agent is from the goal by taking the current state of the agent as input. And this type of technique, heuristic techniques, they are used for optimizing a problem using heuristic function. Okay, and now let us see what is this heuristic function. Heuristic function is a function which is denoted by h of n, okay, and it um, gives an estimation on the cost of getting node n to the goal state. For example, this is node A and this is the goal node, okay. So if you the heuristic function gives the estimation of the cost of the current node to the goal state, okay, and it helps in selecting optimal node for expansion. um okay, so I don't think I need to explain this. Okay, let me give an example of this, of how heuristic function is used. For example, let me say that I want to go from Delhi to um, um, let's take let's say I want to go to Dehradun, from Delhi to Dehradun, and there are two different routes to reach Dehradun from Delhi. Let's say this is route number 1, with which you can reach Dehradun, okay, and there is another route, route number 2, with which you can reach Dehradun, okay. Now, um, as I have said just now, heuristic value is the estimated cost of moving from the current cell to the final cell, right? Just before that, let me give the distance between Delhi to this route number 1. Let's say this is 10 kilometer. From here to here is 20 kilometer, let's say. And from here to here is 300 kilometer. And from here to here is 250 kilometer. Okay, this is 250, okay. And given this functions, given these values, what would be the heuristic value of R1? As I have just said, that heuristic value is the estimated cost of moving from current cell to the final cell, right? So the heuristic value of R1 would be to the final cell, means 300. H of R1 would be 300, and H of R2 would be 250 kilometer, right? Now, uh, how would you select the optimal path using heuristic function? Normally, without using heuristic function, we will select the one with the minimum cost. But using heuristic search technique, we are going to consider heuristic function and its distance between the two possible routes, okay. So what would be the total distance? The total distance would be the distance between Delhi and between these two and plus the distance between Delhi and this R2. The summation of these two makes the total distance, right? Now, R1 would be how much? R1 would be from here. It is Delhi to R1 is 10 plus the heuristic value is how much? 300. It is 310. And for route number 2, you have 20 plus the heuristic value is 250. It is 270, right? So which is lesser? I mean, which is taking lesser distance? R2, right? So you will choose the path R2, right? And another example of a heuristic function is, for example, I have this node x, y, and z, and the heuristic function of this node is 2. Heuristic function of this node is 1, and this heuristic function value of this node would be 0. Why? Because there are no steps beyond this, right? And how do I write 2 here is because there are 2 steps to reach the goal node, and here 1 because only 1 step to reach the goal node, right? So in other way you can say that h of n is the number of steps or hops required to reach goal node from current node. Okay, now let's go to the next. Slide number 16, classification of heuristic function. Heuristic function is classified into 2 types. One is admissible heuristic function, and the second type is non-admissible heuristic function. Okay, let us see what is admissible heuristic function. Okay, so here as you can see, a heuristic is said to be admissible if the heuristic value is less than or equal to the actual value. Okay, here h of n is nothing but the heuristic function which we were just talking about here in the previous slide. Heuristic function, this heuristic function. Okay, so that's the heuristic function, and if that heuristic function of a particular node is less than or if it is equal to the actual node, the actual value, then it is said to be admissible heuristic. Okay, and as I have just said, h of n is less than or equals to h dash n can also mean that it never overestimates the cost to reach the goal. Okay, and by nature this type of heuristics are optimistic. Why? Because they think that the cost of solving the problem is less than it actually is. An example is in 8 puzzle problem, finding out the number of misplaced tiles and application of Manhattan distance. Okay, so that's an admissible heuristic function application. Okay, if you want to explore, you can explore it on your own. I'm not going to do this one. Okay, so let me explain. We're using an example. Admissible heuristic function. Example would be, for example, I am at a node S and I have to go here to the goal node, that is G, and then I have all these nodes in between to the goal node. I can reach the goal node from B as well, and I'm given some heuristic values, 4 for S 3 for A, 1 for C. Goal not has always 0 heuristic value, and 3. Okay. All right. So now heuristic values are given to you. If you have to find write down the value of heuristic value of S, it would be 4, right? 4. Heuristic value of B is 3. Heuristic value of A is 3. Heuristic value of C is 1. Heuristic value of D is 2. And heuristic value of G is 0. So these are given to you. Okay. Now what is the actual cost? Actual cost is from uh, suppose you are you have to find out the actual cost for S. Okay. So what will it be? It is from here till the goal node without taking into consideration the heuristic value. Hmm? So how much it is? Okay, S, let's follow this part. S A C G. Let's follow this path and calculate it. It is 2 plus 3 plus 7. How much it is? 12. 3, 4, 5, 12. No? And how much is the heuristic value of S? It is h of S. And what is the value? 4. Is 4 lesser than the actual value, that is h dash S? Yes, it is lesser, right? So this is admissible. Okay, that's how you prove it. And now the problem comes here. You have the choice to go this follow this path, or either follow this path, right? So how will you know that you have to go this way and this way using this admissible problem? Well, for this you have another function that you have to calculate, that is called consistent heuristic function. Okay, consistent heuristic, that is given by a formula called h of n plus g of n. This h of n is the heuristic cost and g of n is the goal cost. Okay, I'll give an example of this, how consistent heuristic is applied. Okay, so let me give one example. For example, you have this node A. From A you can go to B, you can go to C, you can go to D, and then from B you can proceed further to E and F. F to G, that's the goal node. Okay, and then you have the distance given to you. This is 1, this is 1, this is 1, this is 3, and this is 5, and this is 2. This is the goal node. Yeah, no, this is not the goal node, this is the source. Source. Okay. Now, along with this, the path cost, you are given the heuristic value as well. So the heuristic value of h of B is 3, h of E is 5, h of F is 3, h of C is 4, and h of D is 5. Okay, so these are given to you. Now we are going to look at the adjacent nodes of the source node. What are the adjacent nodes? B, C, and D, right? And what is given to you? Given to us are the heuristic values of B, heuristic value of C, and heuristic value of D. And these are 3, 4, and 5, right? Heuristic value means the cost of reaching the goal node from the current node. For the current node here, for we are at B, so the cost of reaching goal node to from this B is 3. That's given to you, okay? And cost of this heuristic value of C is 4 and heuristic value of D is 5. Now you are going to find out which path to follow after visiting this source node, right? So how will you do that? Using consistent heuristic, you have for if you have as I said, the formula was f of n h of n plus g of n, right? So now f of b, for f of b, it would be the heuristic value of b is 3 na, and the goal node, the goal cost is how much? A to b. Till now we are not considering the rest of the nodes. We are dealing with only this level, till this level, okay? So right now for the current, your goal would be, for B it would be B, for C it would be C, and for D it would be D. F of C is having heuristic value 4 plus 1 is 5, and for D it would be heuristic value plus 1, that is 6. And you are going to find out minimum of these 4 functions B, C, D, which you have just calculated now, and you have for B is 4, that is f of B. So you will choose the node B and explore this path, okay? Now you're going to move forward this. Let me do it in the next page. Now you'll explore B, E, and F. But before that, you have to calculate the actual cost, okay? So what is the actual cost? Actual cost of reaching the goal node, that would be starting from here 1 plus 3 plus 5 plus 2, okay? We are considering this path now, so we are going to take the sum of the the total cost of reaching from A to G, that is 1 plus 3 plus 5 plus 2. Actual cost is 1 plus 3 plus 5 plus 2, that is it 11? It's 11. Now you're going to compare these values with the heuristic value of each of these nodes, okay? Let me write it here again. Heuristic value of B was given as 3. Heuristic value of E was given as 5, and heuristic value of F is given as how much? 3, na? Now if you compare this 3 with 11, it is lesser, right? So it means it is admissible. This node is admissible, and this is also less than 11, it is admissible. This node is also less than 11, so admissible. Therefore h of n is less than or equals to h dash, and hence Ad- admissible. It is admissible. That's how you prove. Okay. Now, after doing all these examples, um, let's talk about heuristic search technique. Heuristic search technique. Okay. So, heuristic search technique, okay, is a technique that helps the AI agent to make intelligent decisions. And by doing so, it makes the algorithm much more efficient. Okay. So, you can say that it helps the, let's write, the artificial intelligence agent to make intelligent decisions. And by doing so, it makes the algorithm much more efficient. Okay. Examples of heuristic search technique would be many, but some of them would be, which I will be discussing in the upcoming lectures. We'll talk about minimax. Okay. Minimax algorithm. You have generate and test. We'll talk a little bit about this. I may give you as an assignment or maybe a little overview of discussion on this. And also we'll do in detail about alpha beta pruning. Okay, so these are some of the examples of heuristic search technique. And um, uh, okay, so how is the artificial intelligence algorithm different from traditional algorithms? Okay, so in traditional algorithms, you have um, such as merge sorting, right? And linear search, right? So how is it different from um, this kind of algorithm? Is that in AI algorithm you can apply decision making, but in case of traditional algorithm you cannot apply, right? And also we're going to study how the AI algorithms are making use of heuristic techniques in the upcoming lectures. Okay, so I think that's all for today. Um, if you have given your attendance, you can leave. Any queries, you may post it or ask. If no queries, then also you can leave.